Now, let's go to question 2.3. So, question 2.3, what they're asking you to do, they are saying, calculate 2.3. I'm not going to continue on this slide, but I have information that I need from this diagram. That's why I'm not going to write anything here. I'm going to write it on the next page. Question 2.3. Calculate the combined mass of the two blocks. So they want us to calculate the combined mass of blocks P and Q. So, to perform these calculations, you need to know the free body diagrams of this and that. That's what you need. So, we do have a free body diagram for this one, which is that. Now, the next thing that you should do is to find the free body diagram of P and blocks P and Q, which is M. So what you should do first is draw the free body diagram of P and Q. So, there are two forces that are acting on P and Q. It's the tension, which is pulling it upwards, and the gravity, which is pulling it downwards. So the free body diagram for M, so this is for the 20 kg block, this one, this free body diagram. So for this one, here is it. So this is the tension, which is equal to that one, but just in opposite direction. And this is the force of gravity, Fg, which is acting on this. So there are two forces acting on this, is this one and gravity. There's nothing on the side because there's no side weight movement that was described. So it's only moving in that direction. So these two free body diagrams are the ones that are going to help us continue going forward into calculating that mass. So you need these free body diagrams in order to use Newton's second law to calculate these. So now, I'll turn over to another page and do question 2.3 on another page. So, on that question 2.3, I'll be using this free body diagram. So you might not really see this, but I'll come back to it in case we need it. So now, let me go to another page and write these free body diagrams and work with them and use Newton 2. Thank you. So I've redrawn this free body diagram. This is the force applied, the normal force, the tension force, the force of gravity or weight, and this is the frictional force on the 20 kg block. So here's the free body diagram for the block M, block P and Q. This is the tension force and this is the force of gravity. Also note, no one told you that you need the free body draw the free body diagram for the second block. But if you want to do the calculations involving the force or weights of another block, you need to have all the free body diagrams. So you were not asked to draw the free body diagram for this one. But it's something that you should be knowing, that if I'm doing calculations on Newton 2 related problems, then you need to have a free body diagram. So let me continue. So this free body diagram is nice because this object is moving downwards, as I said there. So all the forces are either parallel, which is similar orientation, because parallel to the direction of movement, or perpendicular, but we don't have any perpendicular forces. But here, this one, the movement is horizontal. So 1, 2 are horizontal, which is good, and then 2 are vertical, which is perpendicular to the plane of movement. But now we have that one force which is not parallel or perpendicular to the plane of movement or of motion. So what I always advise people to do is try to decompose or break down this applied force such that it is parallel and perpendicular to the motion. So this is how you do this. You break down this such that it is parallel or perpendicular to the motion. So you can see it's going slightly up. So it's pointing in this direction. That means it has a component that is going up and a component that is going to the side, to the left. So that's what you want to do. So let's copy all others that are nice, which is the parallel and perpendicular forces. Perpendicular because they form 90 degrees with the surface. Parallel, they have the same orientation with the surface. So let's redraw all other forces. So we are drawing this one. So this is the normal force, Fn. This is the tension force. This is the force of gravity. And this is the frictional force. So, all the forces that we have drawn here are either parallel or perpendicular to the surface. So what you want to do now is to draw this again such that it is either parallel or perpendicular to the surface. So what you do on this one, you decompose it or you break it down such that you have a parallel and a perpendicular, because you can see that it's going, if you look at this arrow here, let me draw it down here. Here this arrow going this way. You can see that it's moving to this direction. And it's also going up as well. Because if it continues to this direction, you see it's moving in the negative y direction, in the negative x direction, and it's moving in the positive y direction. This. That is what is happening there. So if you are to stretch this and make it bigger, pull it upwards, you see that it's moving towards the negative x direction of the Cartesian plane and the positive y direction of the Cartesian plane. So if you can do this, which means you can split it into that and that. So now you can, since this is your applied force Fa, so you can have force applied in the x direction, which is the horizontal one, or you can have force applied in the y direction, which is the vertical one, and leave this one out. Because these two combined, they make this one using Pythagoras Theorem. Because if you use Pythagoras Theorem of these two guys, you will see that they give you this. Because when when you add vectors, you add them head to tail. So if you can take this vector and move it here, you'll see that Pythagoras Theorem is this one. So let's imagine that you take this one and pull it to this, the tail of this to the head of this, and that head here. You will see that it makes a complete triangle, which is a right angle triangle. So these two both represent that. So what you can do, instead of writing this one, instead of drawing this one, you can draw this FA in the x direction, or you can say horizontal, but it's very long word. I don't want to write that. FAX, you don't need that. And draw another one that goes up. FAY. So these two, FAX and FAY, are these two components of this one. So you don't have to draw this one if you have drawn the components. So if you have drawn the components, the FA, force applied in the x direction, and the force applied in the y direction, you don't have to draw the original one. It's either you draw the components or the original. So I always advise that you draw the original at the beginning, and then when you're doing the calculation, make sure that all your forces are either horizontal or parallel to the surface or perpendicular to the surface. Then from here, you can be able to do calculations. So now the next step that we're going to do is to perform the calculations, because all our forces are parallel to the surface or perpendicular to the surface. So even if you draw this free body diagram, you will be given full marks instead of that one, because this one and that one are considered as the same as one force, because when you combine them, I said if you take this one and put it here, you can see you have a right angle triangle. So when you do Pythagoras theorem of this one, we will give you that, which is the applied force. So it is the same force. So I always, in my school years, I was using this one because this one was helpful for me to do calculations. So now, what we're asked to do is find the mass of M. That's where we're going to start doing the calculations. But if you don't really understand what is happening here, it's going to be hard to perform those calculations. You don't have to do this if you know in mind that you must decompose this into parallel and perpendicular, because you don't have to draw it like this. But it's easier if you draw it like this because it will help you. So I'm going to the next page. On that page, I'm going to only draw this one and that one, because these are the free body diagrams that I'm ready to use that are going to help me perform the calculations. So let's go to question 2.2. So I'm only going to take this one and that one. So this one I'm not going to use because it's not very helpful for me. So you can take it if you know you want to do it. So let's go to the next question. Okay, so I've redrawn this diagram. So what you can see here is this is the free body diagram for the 20 kg block, and that is the free body diagram for the mkg block. We want to find the mass of this unit. So I've explained how we arrived into these free body diagrams in the previous video. So there's no need for me to do that again. So now, what you use here, you use Newton 2. Newton 2 is as follows. F net is equal to ma. So force is a vector and the acceleration is a vector. So what Newton 2 is saying, a net force that is acting on an object will cause an object to accelerate. So the force, all the forces that are, the sum of the forces or the resultant force acting on an object will cause an object to accelerate. And that object will be accelerating in the direction of the force. So if the net force, so the net force acting on an object will cause an object to accelerate in the direction of the force. So the magnitude of the acceleration is directly proportional to the net force and inversely proportional to the mass, which means that the magnitude of the acceleration increases at the similar proportion, at the same proportion as the net force, and inversely proportional to the mass of the object, which means the higher the mass of the object, the smaller the acceleration, and vice versa. So that's what this says. So, which is the sum of the forces is equal to the product of mass and acceleration. That's what Newton 2 is saying. So the net force acting on an object. So the force is the cause. This acceleration is the effect, which means from the sum of forces you get acceleration. So the sum of forces causes the acceleration. So the net force acting on an object will cause an object to accelerate in the direction of the force with the magnitude of acceleration that is directly proportional to the force and inversely proportional to the mass of an object. So the acceleration is directly proportional to the net force, and the acceleration is inversely proportional to the mass, which means now these increase at the same proportion and these ones are inversely proportional. So now the net force. So we can sum all these forces, because the net force is the sum of all forces that are acting on an object. We can sum all of these forces. But I don't like it when you, for example, let's take the vertical forces only. Let's say F net in the y direction of the 20 kg block. So F net in the y, which is in the y direction of the, oh shit, so this should be y, not x. This is y, this is x. So the sum of forces will be equal to what? We have three forces: the normal force, the applied force, and the force of gravity. So now, what you do, you say the net force is the sum of forces. You add these forces. So, you say, okay, we have normal force, Fn, plus Fa, force applied in the y direction. So these two are going upwards, and this one is going downwards, which means they have different directions. So if you made these two positive, this one, if you made these two positive, this one will be negative because it's going to the opposite direction. This one is negative, which is Fg. So you don't have a motion in the vertical direction. So this is not moving in that direction. So it's sitting on the surface, which means these two forces balances out. Which means the sum of these two forces is equal to the sum of those two forces. Which means if they are equal, these two forces minus this one should give you 0. Let me explain it again. I'm saying that you don't have a motion in the vertical direction. Your object is moving in that direction. So since it's moving in the horizontal direction, which means your forces that are here are not balanced. But now, in the vertical direction, you don't have any movement on this one, on the 20 kg block. Which means these two forces are, so the sum of these forces is at equilibrium, which means this object is at equilibrium. It's not moving in the vertical direction. It's still. That means that if you take the sum of these forces, of vertical forces, and the sum of vertical forces, they are equal, which means now the vertical forces equal the upward forces, the sum of these two forces are equal to this one. So if you're saying that these two are equal, that means that if you add these two and subtract them with this one, the answer will be 0 because you said this and that are equal. So if you have them equal, then same thing minus the same thing, which is x minus x is 0. Because you're saying that the equation, these two maybe is 5 neutrons and this one is 5 neutrons. So 5 minus 5 is 0. So this plus this equal to that one. So if you say the sum minus the force of gravity, it should give you 0 neutrons. So there's no point in using the vertical forces for finding your net force, because if you're using your vertical forces to find the net force, these vertical forces will cancel out. So to make your thing less complex, only use these forces that are in the direction of movement. So only focus on these horizontal forces, and leave these ones alone. You don't need these ones because they are going to cancel out because you don't have the motion there. But if you have the motion in this direction and that direction, then you are going to use all of them. But now your motion is only horizontal, so focus on the horizontal forces only. For example, here the movement is downwards here. This block is moving down, which means now you only focus to the forces that are parallel to the plane of movement or to the direction of movement. So now these forces are okay, you're going to use them. If you had forces in that direction, but there was no movement there, so you're not going to use those forces. So now, here is what we should be doing. So now we are going to I'll go to the next page and we do the net and find the net forces for this one, which will be the horizontal forces, and that one, and perform our calculation. So you don't have to use these ones if you don't need to. So you only use them when you need them. If there is a motion or you need to find kinetic friction or dynamic friction or static friction, then that's when you start using them. But for now, You don't need them. So what we're going to do, on the next page, I'll redraw these two and start performing the calculations. So now, on this video, I'm explaining everything because I will always reference you to this video when I'm doing, because these questions are similar. I'll meet a question like this down the years or backwards when I'm doing other papers, but I will not explain as precisely as this one. So I will always reference you to this one. So this will be the longest for the horizontal cases. So then the rest I will always explain and then always keep referencing the previous video. So now let me redraw this and perform the actual calculations. So my point was that when you're calculating the net force, don't include the forces that are not in the plane of movement. Only include those that are on the plane of movement. So on the previous free body diagram, where you had the normal force up there, it was going to be tricky because what were you going to do with that force? Nothing. So there's nothing much that you're going to do with that force. Because you will see that you say, okay, someone was going to say, okay, it's not in the plane. It's not in the plane of movement. So I'm going to leave it out. Yet it has a component which is in that plane. So that's why I prefer this one, because this one shows you all the components that you need. Okay, so now what we are going to do is finding the net forces. So we start. F net is equal to MA. So F net is the sum of forces. It's equal to the product of mass and acceleration, which is Newton 2 by definition. So now, what we do here, we said that we're going to sum the forces that are parallel to the plane of motion, which is these 1, 2, 3 forces. So now, when you do this, you have to decide with the signs. So what I always do, I assume the direction in which the system is going as positive, and then all forces that are operating in the opposite direction of the motion of the system, I take them as negative. So we said this one is moving to the right and this one is moving down. So the right will be positive, all the forces to the right will be positive, all the forces down here will be positive, and then all the forces that are opposing the motion will be negative. So here, which means in this case our tension is negative, is positive. Then these two are negative. So now, for the net force, which is this part, you have, okay, you are summing your forces now. So we have the tension force plus negative frictional force plus a negative force applied in the x direction is equal to MA. This is for the 20 kg block, this one. So now, to simplify it, you say, okay, T minus frictional force minus FA in the x direction, which is horizontal, is equal to MA. So this is the equation for the net force for the 20 kg block. So same thing for that one, for the m kg block. F net is equal to MA. So you are going to sum your forces, which is now, this one will be positive because the system is going down, which means FG minus tension, sorry, corona, tension is equal to MA. So you can say plus negative tension, which is equal to MA. So this one, FG minus tension is equal to MA. So here is your sum of your net forces. So you have these two. What they want you to find, they want you to find the mass of that. So now we proceed with the calculation. So we have managed to set up these two equations. So now let's continue with our calculation now. So to continue with this, let's do this. So it's 2.3. So now we know that T minus frictional force minus, what is it? Minus FA, first force applied, which is the X component, is called MA, and FG minus T is equal to MA. So this is the first one is for the 20 kg block, and the second one is for the M kg block. So what I would like you to know, to keep in mind here, you were told that on that question that the system that is moving at a constant speed. You're told that it's moving at a constant speed. If you notice there, that constant speed is even highlighted in capital letters. What that means is, if your system is moving at a constant speed, that means it is not accelerating. So, which means the speed is not changing. What acceleration is the rate at which velocity changes. Which means how much is your velocity changes. Can be decreasing, can be increasing. Which means here, if they say constant speed, which means they say there is no acceleration all the time. That's what this means. So if you're told that it's moving at a constant speed, know that the acceleration is 0 meters per second squared. And if this is the case, and if the acceleration is 0, you know that F net is equal to MA, but you know your A is 0, which means your F net is equal to M times 0, which means your F net is equal to 0 newtons. So we know from constant speed, if you're told the speed is constant, acceleration is 0, and the net force is 0, which means we have 0 in both of these positions. So we have 0 here and 0 there, which means the sum of these forces goes to 0. And the sum of these forces goes to 0 because it's the system, or the velocity is constant for the entire system. So now we are very close I'm just setting this up. On the next videos I won't be doing all this for similar question. I'll only be doing the questions. So I told you that on your applied force, you can split it into this component, which is Fx, and that component, which is Fy. So now, this is your Fay, Fax, this is your Fa, your original force. You have your angle here, theta, which is 40 degrees in this question. So you can find this, the value of this force and the value of this force using the trig functions. For example, this one, you are given the original force and the angle. You want the adjacent. This is cos. So cos theta is called opposite adjacent, which the adjacent is Fax over hypotenuse, which is Fa. That means now you want to solve this cross multiply. Fax is equal to Fa cos theta. So that's how you find this, the value of this. So you know Fx or Fax is equal to Fa cos theta. Fay is equal to Fa sin theta. So when you're performing the calculation and you have used Fx, this is what you put in the place of Fx. So you have the force applied, you have the angle with the horizontal. Same thing, if you want to use this, this is how you this is how you do it. So I'm going to the next slide where I'm going to continue with this and that. Because what I don't want to do, I don't want just to be solving the questions. I just want to explain them to you so that in future you know what you're doing. So what I'm going to do now, I'll take this equation and this equation. and place the zeros there. And instead of this, I'm going to substitute this, the equivalent of this, and perform the calculation and find the mass m. Then I'll be done with this question. Okay, so I just copied these two equations and those ones. So we'll do the calculation now. So what they want us to do is find the mass of the block. You know, you still remember the question. You can go back if you forgot. So what you do here, the tension, you're not given the tension. Let's use this first equation. So the tension you're not given, minus frictional force, okay, minus FAX. FAX is this, which is you put FA cos theta is equal to 0. So now you don't have tension minus frictional force. They said frictional force was 5. FA minus FA 35 cos 40 degrees is equal to 0. So from this equation, you will solve for T. So punch this on your calculator. Negative 5 minus 35 cos 40. So you have T minus 31 comma 81 is equal to 0, which means you can transpose this to the other side, which means your tension is equal to 31 comma 81 newtons. This is your tension. Now you go to your second equation. Second equation, you have Fg is minus T is equal to 0. Fg is the force of gravity. To calculate the force of gravity, it's simple. It's Fg is equal to the mass times gravity, which is 9,8. So now, there you have Fg minus tension is equal to 0, which is equivalent to saying mg minus tension is equal to 0, because this is gravity. This is how you calculate gravity. And then from here, said okay, mg, in m you don't know m, g is 9,8 minus tension, which is 31,18 is equal to 0. So you can proceed with this to the next page. So you have mg, m times 9,8 minus t, which is 31,81 is equal to 0. So you have 9,8 m is equal to 31,81. So divide by 9,8, divide by 9,8. This cancels out. M is equal to 31,81 divided by 9,8, which is 3.25 kg. So this is the mass of that unit. So this is how you do that question. So this is the end of it. So it was straightforward, but I took all this time because I want to make sure that you understand what you should be doing or what is expected of you.